The last hard one really did kind of kill my soul a little bit. It being something I previously solved but got stumped on. Oh my god. Anyways, streak of 0. Excuse me. Streak of 0. I wonder if I ever get to something like a 3-digit streak again. I think I had those at the start. Oh my god. Anyways, minimum absolute distance between mirror pairs, medium. You're given an integer array nums, a mere pair of indices ij such that 0 is less than I, less than j, less than nums at length. Reverse at nums at I equals nums at j, where reverse at x denotes the integer form by reversing digits of x. Leading zeros are omitted after reversing. 121 or 120 is reversed to 021, which is the same thing as 21. Okay. Return the minimum absolute distance between the indices of any mere pair. Minimum absolute distance between the indices of any mere pair. Okay, the smallest pair of indices, or the pair of indices with the smallest difference between them. Okay, so the closest pair of indices. Okay. Yeah. Where you have the same values that are mirrored of each other. So here it's going to be 21 and 12 mirrors into one difference. Technically 45 and 54 mirrors, but they're two difference in terms of indices. Yep. This 1, 0. Oh, sorry. This is not 21 mirrors to 12 rather than 120. So this is okay. There's no okay. Yep. Simple enough. Okay, so I think this is just going to be for each value. I'll iterate over them, and then I'll make a hash. I'll make a set, maybe of themselves or of the mirror of them. And then if I find themselves or that mirror version kind of later on, then I know that, okay, I do need to know the index where they occur. So I'll go ahead and create a hash map. Okay, so yeah, I'll create a hash map. Map value to index, because you kind of need to know that, right? I think, is there any edge cases I need to worry about? 12, 21, 210. I think there is something I need to worry about here in terms of leading zeros, because let's say you have there's some slight non-1-to-1 mapping, like there's either like 1-to-2 mapping or 2-to-1 mapping, something like that. So 120 maps to 021, and 1-2 maps to 2-1. Okay, so there you go. So 1-2 mirrors to 21, and 12 mirrors to 21. So I think that means that I need to store the expected mirror, because if I store this value, right, if I come across 21 later on, I don't know whether or not I should be looking for 120 or 12. But if I know that the value is 120, then I can store 21, and if I see 21 later on, then I know that that works. It doesn't work the other way around. Like if I store, let's like that, right? If I store 21, technically 12 or 120. Actually maybe it doesn't matter. So if I look at this, actually, so if I store, if I'm on a particular value, for a particular value, the mirror of it is unique? No. All right, come on. So if I see 120, if I store 120, then when I see 12 later on, or see 21 later on, if I see 120, I should store 21. If I see 21, what do I store, right? Okay, maybe what I need to do is actually, if I see 120, I need to store 12. I need to store the number removing the ending zeros, because those ending zeros won't be actually anything when I do the reverse. Is that right? So then when I see 21, I can look for just 12. Okay, yeah, so then the thing would be, if I see a number, I store the number removing the ending zeros. Yeah. Okay. So for every value in the nums array, I remove ending zeros. So while the value mod 10 is equal to 0, value divided by equals to 10. Let's see, previous mapping is going to be a dictionary. Previous of this value, whoops, previous of this value is equal to this mapping, to this index. I need index, huh? Okay. Index in range n. My god, my typing is horrible. The value is the thing at this index. The previous of this value is this index. Okay, and then let's say answer equals -1. I think answer should be infinity. And then it minimizes over time, right? If so here I need to actually do the reverse. I'll just go ahead and make a helper function, I think. I'll do the reverse of some value, returns a value. Let's go ahead and try to do this in Python 3 syntax. Reverse is equal to, I guess I'll just start with value mod 10, while value doesn't equal 0. I'll do reverse times equals 10. Reverse equals reverse times 10 plus value mod 10. I don't know order of operations for this. I used to. Not really. So that should reverse it and then remove the last digit from value. And then return the reverse. And let's go ahead and just verify that this is correct. Let's say print the reverse of 120. Print the reverse of, let's say, 31.4. What else? Print the reverse of a one-digit number. Okay, let's see if the reverse does it correctly. Should say 21. Oh god. Should say 120, 214135. Okay, fine. Please stop giving me errors and the other stuff. 21, oh boy. Okay, I think, yeah, okay, yeah. It's not doing the starting bit correctly. Okay, I think it should just be 0 here. Yeah. Okay, that is fine. Yeah. All right, so previous value, if the reverse of this value is in this map, then answer equals the minimum of answer and the index, the difference in index. So this index minus the previous of this thing. Previous of, I guess, reverse of, okay, this is, I need to store it. Previous and reverse are actually spelled very similar. Or the contraction of it. Okay. I think this might work. Okay. Okay. So index 0, value equals 12. And then I remove the ending zeros, which there aren't any. And then previous of this value equals index. Previous of 12 equals 0. Reverse of the value. Reverse of 12 is 21. It's not in that. So it goes on to the next one. Index is 1, value is 21. Doesn't do anything here. Previous of 21 is now 1. Reverse of 21 is 12. If 12 is in previous, which it should be, answer equals min of answer and this index minus previous of, that should be 1 right there. Okay, what was wrong? Somehow I got 0. Okay. So how did this thing get 0? What's going on? Oh, I see. Yeah. 33. That's a it fails. It fails on the same. Okay, sure. Okay, there's definitely a couple mistakes here. Just finding everything funny today. Okay, if the answer is equal to infinity, I need to return -1. Okay, I always do this kind of in Java-like syntax, and then I change it to the other syntax. Return -1. If answer is equal to infinity, else return the answer. Okay, so if, I think it needs to be like if the value doesn't equal reverse, otherwise it's just, it actually, it can, right? It could be 33 here and another 33 somewhere else. Okay, so what I need to do is I need to not do this. It needs to be like this order, or this thing has to be here, regardless of like 33 being kind of a, I'm not sure how to say this, but the order has to change. I need to check for the reverse first, and then store the reverse. Yeah, this should work. Or I'm pretty sure this should work. Fuck. Okay, so it does this one right. 21 and What is it doing here, really? The reverse of this is 0, 2, 1. No. Reverse of 1, 2, 0 is 2, 1. Yeah. Pretty. Let's do this. 1, 20, 21. 0, 2, 1. Where x denotes the integer after reversing. Leading zeros are omitted after reversing. So for example, the reverse of 1, 2, 0 is 2, 1. 1, 2, 0. The reverse of 1, 2, 0 is 2, 1. There are no mirror pairs in this array. Hmm. 1, 2, 0. I'm missing something stupid here. Leading zeros are omitted after reversing. The reverse of nums at I equals nums at j. So I guess I can't do reverse of this thing is equal to this. So reverse of this thing is equal to a later value, but the reverse of this thing is 20. Okay, I see. I was worried about both sides of that. Okay. So this is going to be 12. Oh, okay. So I don't need to remove the zeros, I think. Yeah, I don't need to remove the zeros. Because this thing is just going to become 21. Do I? I definitely don't want to remove the zeros for something here. I think I store the reverse that I'm looking for. I store the reverse I'm looking for, yeah. Okay, so this should be something like reverse is equal to reverse of value. Previous of the reverse is equal to this index. Actually, I think this should be if the value is in previous mapping, answer equals min of answer and previous value minus, or index minus previous value index. Okay. I think that's it. Kind of butchered the reading of this thing. Yeah. Yeah. Butchered my reading of the problem. I thought it was actually, like I totally misread this. Thought I was going to do the same for both. Oh man. Okay. Hmm. 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 Is there wonder if there's a faster way to reverse an integer? Is that what's missing here? Hmm. Is that what's missing? The values in previous. Do. This is mapping E is equal to this, and the value, or yeah. Do. Huh. What is slow about my thing? What is slow about this? Okay. I'm just gonna, out of curiosity, because sometimes you just need to check that your baseline is correct in terms of like your building blocks of your algorithm is correct in terms of being fast. Fastest way to reverse an integer. Like in theory, I can. In theory, I can do this. Yeah. Convert to a string. Okay. Okay. Let's see if that. I'll call this reverse slow. I mean, I ideally want to call this reverse fast, but whatever. Return integer of the value converted to a string. Yeah, a string of the value. Made, copied, reversed. Yeah. Do. Okay, so that was most of the speed slow down compared to maybe most of those solutions. I wonder if I should use enumerate here. I think enumerate is the one that has the index and value. Yeah, is enumerate faster? Is that faster? Okay, I'll see this. So it's index and then value and enumerate of the thing. And enumerate of the array. I recall doing some problems where it wasn't really getting any or even was slower on Python test cases. Yeah, just doesn't go faster. I don't know why. I mean, seems like it should. Okay, this is just that's just random. This is random. Okay, let's see. I mean, theory, you could use this if statement here so that you didn't always change it. I mean, I guess here you could probably just call it without using a variable. Guess that might be a minor speed up. Or just random. Okay, I'm good with this. Okay, summary. So make sure to read the examples closely, unlike me to start. Basically use a hash map which will store the reverse value for a particular value in the array that you are looking for. So yeah, the map will go from key is equal to the reverse value, and the value that that key matches to is going to equal the original index or the index of the original value. So i.e. if the value is equal to 12, the map will be from 21, the reverse is equal to, let's say index 3, then this is going to equal 3. So iterate over the values in the array, check to see if it is the reverse of a previous value, right? Kind of update answer if it is. If the difference in index is lower, otherwise, you know, update the hash map for this value. So find the reverse of this value, store the index as the value to the key of that. Also, use the string kind of reverse. The fast way of reversing an integer in Python is via integer to string to kind of reversing using array reversal there with like the bracket colon -1 bracket, right? Back to integer. See the helper function. So I originally tried just the kind of normal way that I'm used to, which is using modular arithmetic, getting the last digit of a 10-digit number, attaching it to another number that is appending those digits, kind of. Anyways, time complexity is going to be O of n, where n is equal to the length of the array, as you might need to iterate over every index in the array. It's not going to be much more than that. Adding elements to a hash map or reversing the integer should be constant work. And obviously looking up in a hash map is constant work. Space complexity is going to be O of n, since the hash map could have all the values.